Hello everyone. Today we'll be talking about trial and improvement. This is the subtopic and solving equations. Okay, now let us begin. We have a couple of information here, and we discussed this information in class. And if you don't mind, you can pause the video and go through this explanation about trial and improvement. Okay, but without wasting time, let us start answering some questions here. Okay, this is my worked example number 1. The question is use trial and improvement to find a positive solution to the equation x times x minus 2 equals 60. And give the answer correct to 1 decimal place. Okay. Basically, what we are supposed to do here is we have to use a calculator to start filling up the table. Okay, so what we do, we ignore this equals to 60. We ignore this. We ignore this temporarily. And then in the calculator, we store the function y equals to x minus 2. We store this function in the calculator. All right, so just make sure that you have a calculator ready. And this is the way how we store the function in the calculator. Okay, so what we are supposed to do over here is to store this function y equals to x minus 2, which is done as follows: alpha y equals to then alpha x open brackets alpha x minus 2 close bracket. Okay, then you press this button here, calculate button, press that. Now it's asking you to test or to try some few values here of x. Now let me try with x equals to 6, for example. Okay, so here we try x equals to 6. You try any value, let's say x equals to 6, and this part you'll be giving the comments whether the answer you got is bigger than 16 or smaller than 16. So here the comments will be smaller or bigger than 16. Bigger than 60. Okay, that would be the comments that will be writing in this column here. All right, now let us start with x equals to 60. So calculate y when x is 60. So you type here 6. Okay, it is equal to. So when x is 6, the value of x minus 2 is 24. So you write over here 24. So you compare this value 24 with this 60 here. So you find that 24, we were supposed to get 60, but we got a number 24 which is smaller than 60. So here we write smaller. Smaller compared with the answer which we were expecting. Right, so you try, since this is smaller and we are expecting to get 60, so you try the number next to 6, that is 7, and then you do the same. Calculate the value of y when x is 7. It is equal to, you are still getting 35. Now 35 is still smaller than 60. So the comment here will be smaller than 60. Then move higher. Try after 7, try 8 and see what you get. So calculate Calculate y when x is 8. What is the answer? It's 48. 48 compared with 60 is still smaller. So you write smaller than 60. Then you try the next number after 8. We try 9. And then, so we come back here, calculate the value of y when x is 9. Okay. Now, we got 63. Okay, now 63 is bigger than 60. So you can see that. 63 is bigger than the expected value, which is 60. So here we write bigger. Okay, we write bigger. Then after that, when you get this indication here, let me show you. When you get this indication here, smaller and bigger, okay? When you get that, check the way how we started. We are getting the answer smaller, smaller, smaller. Then when you get bigger, that indicates that the value of x here is between 8 and 9. Okay, when they start alternating, this is smaller and this is bigger, so that suggests that the answer is between 8 and 9. So the interval over there is between 8 and 9. So here we'll be checking, or we'll be substituting the numbers which are between 8 and 9. Okay, so we start the process. Okay, now let us check 8.5. Let us try to substitute x as 8.5. So the answer here, 8.5, you take your calculator and then you calculate the value of y when x is 8.5. Do that. You see, you are getting something smaller than. Okay, so we are getting 55.25. So 55.25 is smaller. So you start the process again until you get something bigger. Right, so 55.25 is smaller than 60, so you move ahead one more step. 8.5, then you move to 8.6 and then check what you get. So calculate that. We have 8.6 over here. You're getting something smaller again, so we got 56.76. Again, we got something smaller. Okay, then you have to extend your table. You have to extend your table like so. Extend your table and then try 8.7. Okay, 8.7. So calculate y when x is 8.7. See that? I'm getting 58.29. Still, this compared with 60 is smaller. Okay, then try the next number here. After 8.7, you try 8.8. Okay, so we try 8.8. So calculate y when x is 8.8. We got 59.84. 59.84. This is still smaller. 59.84. Then you move to the next number after 8. After 8.8 is 8.9. So we calculate that. Okay, so 8.9, calculate that, 8.9. Oh, we are getting 61.41, something which is bigger than 60. Okay, now this suggests again, when you get that, Remember what we said? We are getting smaller and then bigger. So this suggests that the answer lies between 8.8 and 8.9. So you see that? So you start again checking the numbers which are between 8.8 and 8.9. Okay, so we have got the new interval which is between 8.8, the new interval which is between 8.8 and 8.9. So you start the process again. So this time I'm going to start with 8.85. The number at the middle of 8.8 and 8.9 is 8.85. So I try that to see what will be the next attempt. So we try, take the table, try 8.85, calculate that. So calculate 8.85. We are getting now a number which is bigger than 60. Got 60.625. So we're getting something bigger. Now, getting something bigger than 60 suggests that we'll be trying numbers which are less than 8.85. So I will be trying numbers which are less than 8.85. Okay, so 8.85. Let us try numbers which are less than 8.85. Let us try, say, 8.83, for example. That is less than, okay. Substitute, okay, so calculate 8.83. We are getting again a number bigger than 60. So 60.3089. Okay, 89. So we got something bigger. Okay, now let us try the number 8.82. Let us see, calculate that. 8.82. We are getting again the number bigger than that. So 60.1524. We got something bigger than 60. Okay, so let us try 8.81, for example. Calculate 8.81. We got something smaller than 60, so we stop there. We got something 59.9961. So we got something smaller than 60. So that indicates that our answer is 8.82, 8.81. This is where our answer lies. See that? 8.82, 8.81. Now, because the instruction of the question says give the answer correct to one decimal place. Now, if I pick, for example, 8.82, if I round this answer to one decimal place, this answer is two decimal places, two decimal places. So you put a boundary here, and then you check to your right. To one decimal place, the answer would be 8.8. even if when I take 8.81, I round this answer to 1 decimal place, I will still get 80.8. So here, the value of x, this suggests that the value of x to 1 decimal place will be, here you're right, the value of x correct to 1 decimal place will be 8.8. This is the answer. All right, let us proceed. Let's proceed to this question over here. Work out a positive solution of each of these equations by trial and improvement. Work out a positive solution of each of these equations by trial and improvement. So here what we are going to do is we need a table. A table, say, with okay, let us say 1, 2, 3, 4, 5, 6. Okay, right, this is the table. Okay, a table which has 1, 2, 3 columns and 1, 2, 3, 4, 5, 6, 7 rows. Okay. Okay. Once that is done, and then we go to the process of trial and improvement. Okay. Let us make this a little bit not wider. Okay, so these will be the values of x we'll be trying, and this will be our x power 3 plus x, because we have to ignore this one here. Ignore that for now. And then here we'll be writing the comments, either too small, or too large. Or you can just write, you can just say smaller than the expected, or bigger than the expected, and the expected value here is 95.625. Okay. Now let us start x equals to, say, let us say x equals to 2, for example. Okay. Now 1, 2, 3, 4, 5, 6, 7. Okay. Let us start with x equals to 2. And let us take the calculator and try to store this function here. We are going to store this function here in our calculator. The function will be y equals to x to the power 3 plus x. This equals to 95.625. Just ignore that. Okay, so take your calculator and then store the function in your calculator. All right, let me clear everything. All right. Now let us store y equals to x power 3 plus x in the calculator. So alpha y equals to 1 minute. Alpha y equals to, then you write alpha x to the power of 3, then plus alpha x. Then let us calculate the first value. X is 2. Okay, x is 2. Now when x is 2, we got 10. Is it? Yes, okay. We got 10. Now when we compare 10 with 95.625, when you compare 10 with the expected answer, 95.625, you find that 10 is still too small. Now if it is too small, then we move ahead to 3. Okay? Calculate the value of y when x is 3. That gives you 30. 30 compared with this number here. 95.6 is still too small. Okay, then head over to 4. Then calculate x when calculate the value of y when x is 4. I'm getting 68. Now 68 compared with 95.625, still it is too small. Okay, head over to 5. Calculate the value of y when x is 5. Oh, I'm getting 130. 130 is too big or too large compared with 95.625, the expected result. Okay, now this suggests that we have too small when x is 4. We got a result which is too small when x is 4, and we got a result which is too large when x is 5. So this suggests that our answer will lie between x equals 4 and x equals 5. Okay, so here pull out your number line and then try checking, or try values which are between 4 and 5. Now we start with a number which is exactly halfway between 4 and 5. So we start with 4.5. So try 4.5. Okay, so calculate the value of y when x is 4.5. Oh wow, we are getting 95.625, which is exact. 95.625, which is perfect, which is exactly with what we are looking for. Okay, so then since you got something exact when compared with the expected, you see, x power 3 plus x should be giving you 95.625, and this is what we got. But what do we write as a conclusion? We write that the value of x, that is giving 95.625. So here you conclude your trials. Here you conclude, underneath your table, you conclude that the value of x which we got is 4.5. See that? This concludes your trials. All right, you can pause the video and take some notes. Otherwise, let us proceed. Okay, here we go. We have another function, and the instruction is still the same. The instruction is work out a positive solution of each of these equations by trial and improvement. Okay, the same instruction works over here. So we are looking for the value of x, which when substituted in here will give you the result 1320. Okay, so here we need to present our trials in a table form. So we need a table. We need a table for the values of x, the results, and the comments. And then how many rows do we need? Let's check. 1, 2, 3, 4, 5, 6, 7, for example. Okay. All right. So the first column, values of x will be there. The results will be recorded here. So here we need one column for the trials, and another column will be for this function here, because we have to ignore that result temporarily. Okay, so here we type x plus 1. Let's make it a little bit wider. X plus 1, x plus 2. Okay, and here, we do the comments. So the comments which we normally use is smaller than the expected or bigger than the expected. So here the comments will be, you can say too small or smaller than or bigger than. Bigger than. Now bigger than what? Bigger than 1320. So this is what we'll be comparing with. Okay, now let us start with say the smallest number. If you start with x equal to 1, that is very small trial. Okay, let us say x equals to 4. Okay, let's try x equal to 4. Now we have to make sure that we clear our calculator so that we can, okay, yes, we have to clear our calculator so that we can fill up this, we can store this function in our calculator. Okay, now here we go. We have alpha y equals to, then alpha x, open brackets, then alpha x plus 1, close brackets, then open brackets, x plus 2, alpha x plus 2, then close brackets. Okay, now let us check our function. Our function is now stored in our calculator, Okay, x plus 1, x plus 2. Okay, now let us start calculating the values. Calculate the value of y when x is 4. Okay, it is equal to, okay, I'm getting 120. I got the result 120. Now 120 compared with this result is too smaller. So here we write smaller than. Or we can just comment by writing smaller instead of putting so many explanations. So here you write smaller. Right, and here after, because we got a result which is smaller than the expected, so we have to move higher than 4, that is 5. So we go back to our calculator, calculate the value of y when x is 5. I'm getting 210. 210 compared with the expected 1320, still the result is smaller. And then I got the result smaller, so I got to calculate y when x is 6. So we try 6 and we got 336. Still we are getting a result smaller. Now do x is 7, for example. Calculate y when x is 7. I'm getting 504, still is smaller compared with 1320. Then try 8. Calculate the value of y when x is 8. I'm still getting 720, something smaller. And then try x is 9. Try x9. Here we are going to try x9. We are going to get something 990. Compared with that, still we are not getting the expected, so smaller. Try x equal to 10. Calculate the value of y when x is 10. Try that. What? 1320. Let me check this. 1320. Wow, we are getting something exact. So 1320, we got something exactly. See that? So here, what is the value of x? The value of x equals to 10. That is what we conclude with. Done. You can pause the video and try to see how you can copy the notes, but this is the way how we do trial and improvement. Okay, next question is this one here. Let me check how much time has gone. Still have 30 minutes have gone. Let us pull on. Put in the value of x squared minus 3x when x is 6. Put in the value. Okay, we want to find the value of x squared minus 3x when x is 60. When x is 6, put in the value. Okay. One has been done as an example, right? Now use try and improvement to find a solution of the equation x squared minus 3x equals to 16. Record your trials in the table. Record your trials in the table, and more rows. Add more rows if you need them. Give the answer correct to one decimal place. Guess here we'll need some rows. One row should be for comments. One column. We need one column here for comments. Okay, we need one column here for comments. We need 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Okay. This will take so much time. Okay, let me do it. Let me do it manually. All right. Now put in the value of x squared. So we will need one column here for comments. Okay. So we'll be telling whether it is smaller, or we'll be telling if it is too large or too small. So here, too small or too large. All right, now let us start. We have to store this function in the calculator. Okay, store this. This is x squared minus 3x. This is the function I'm talking about. Okay, so we have x squared minus 3x equals 16. We have to ignore equals to 16 and just move on. So we have alpha y equals to, we have x squared minus 3x minus 3x. Okay. Now we need to calculate y when x is 5. We got 10, that has been done for us, and then we have to calculate y when x is 6. We got 18. Okay. Now we got 18. However, we are targeting the answer equals to 16. So getting 18 suggests this is too large. So you write here too large. And for this one, we got x, when x is 5, y is 10. So this is too small. Okay. Now, when you substitute x equals to 5 and you are getting a number smaller, and when you substitute x equal to 16 and then you get a number larger than expected, this indicates that our answer is between 5 and 6. This is what it means. Okay. Okay. Now, let us try with the number which is exactly halfway between 5 and 6, and that is 5.5. So substitute x equals to 5.5. Okay, so we have calculate y when x is 5.5. I'm getting 13.75. Okay, so when x is 5.5, we got something smaller than 16. So here we got 13.75. 13.75. Now this 13.75 is something smaller. So you write here too small. Too small compared with 16. Now because we got something smaller, when you substituted x equals to 5.5, you got something smaller than 16. So you have to go higher than 5.5. You have to go higher than 5.5. You have to go higher than 5.5, like 5.6. Now substitute x here, 5.6. See that? What is the answer? Okay, so here we do calculate y when we have 5.6. Try 5.6. Still you are getting smaller. 14.56. 14.56 is smaller than 16, so too small. Now that is when he said add more rows. So we are going to add more rows here. How many rows we don't know. So that is why it is known as trial and improvement. Okay, so let us add some rows here. Let's add some rows here. You can add a good number of rows, doesn't matter. And because we add rows with pencil, so you can later erase them if you have got the exact answer. So 5.5, and then try 5.7. So 5.7, try that. Okay, here we go. 5.7, try that. I'm getting 15 point. Okay, 5.7, 15.39. Okay, still is smaller than 16, so too small. Okay, and then we go to 5.8. Try that. 5.8. So calculate y when x is 5.8. 16.24 is higher. Okay, so 16. Okay, we got 16.24. Too large. Now remember what I said? Here we were getting too small. Then we have got too large. That means this answer lies between 5.7 and 5.8. So you start again checking. You start again trying. Guess let me draw another number line. And this number line is between, we have to check numbers between 5.7 and 5.8. Too small, too large. Okay. So 5.7, 5.8. This means our final answer will be lying between 5.7 and 5.8. So we try a number exactly halfway, 5.7 and 5.8. And that is 5.75. Okay. So you start again afresh. So 5.75. Because you are looking for the answer correct to one decimal place. So try 5.75. Go back to the calculator. Try 5.75. Try 5.75. That equals to a number 15.8125. 15.8125. Still, compared with 16, that is too small. So you start a process again until you get too large, and that is where you stop when you get too large. Okay, 15.8125. So you go higher because we got a result something smaller than 16. So you have to go higher than 5.75. So this will be 5.76. Try that, 5.76. So calculate 5.76. 5.76, it is equal to, I'm getting 15.8976, still small. 15.8976. So this is still too small. Remember, my target is to get equals 16. So try 5.77. Try 5. So calculate the value of y when x is 5.77. Still I'm getting a small result, 15.9829. So still this is too small compared with 16 that we are looking for. Try 5.8. I mean 5.78. 5.78. Let us see. Try 5.78. Oh wow, there we are getting a number bigger than 16. So there you have to stop. We are getting 16.06, 16.0684. So we are getting a too large result. So there you stop. Now when you stop, that suggests the answer can either be 5.77 or 5.78. Now, because the question is saying give the answer correct to one decimal place, so you can see that if I take this answer 5.77, round it to one decimal place, I will get 5.8. You know the procedure. And if I take this 5.78, round it to one decimal place, still I'm getting 5.8. So both of these answers to one decimal place, they are giving me same result. Same result, which is 5.8, 5.8. So what does it mean? Our x to one decimal place will be 5.8. There you stop. That is your answer. Okay, I hope that helps. Let us still continue. We are talking about trial and improvement using a calculator. Right. We have another question over here. We have another question over here. The equation 10x minus x squared equals 20 has two solutions. A, one solution is between 2 and 3. Okay, one solution is between 2 and 3. Use trial and improvement to find it. Give the answer correct to one decimal place. Okay. We need a table to do this. We need a table to do this. And here we are given the interval to start with. That the equation 10x minus x squared equals to 20 has two solutions. But one solution is between 2 and 3. So we are given the interval to start with. That one solution lies between 2 and 3. Now we have to figure out what is that. And we have to give our answer correct to one decimal place. Okay, so at least this question is almost straightforward. Okay, so what we need here, we need a table. We need a table with 3 columns and how many rows? Let us put like yes, a table like this. If it is not enough, we are going to extend it. Okay, this one should be a little bit, not that much wide, but this one for comments and trials. Okay, so we need a table. We need a table of this kind. And then let us start trying some values. The first values to try are 2 and 3. So we start trying 2, and later we try 3. Our function is, we ignore equals to 20, and then we put here 10x minus x squared. This is the function we'll be storing in the calculator. And here we will be talking about the comments. Now the comments which we prefer most is smaller than or bigger than. Another type of comments is too small or too large. So let me go for too small. If not too small, it will be too large. Okay? Too small or too large. These are the typical, comments we prefer. Now let us store this function. Let us store this function here, 10x minus x squared, in our calculator, and see how the trials will be approaching the answer equals 20. Okay, so take our calculator, make sure that our calculator is clean. You have to clear your calculator. Okay, so save that alpha y equals to, we have 10x alpha, x minus alpha x then square. You can see that? Right, now after that, then we try x equals to 2 and x equals to 3. Why? Because they told us that the one solution which you are looking for is between 2 and 3. So you start trying 2 and later 3 and see how it behaves. Is it too small or too large compared with equals 20? Okay, now let us calculate the value of y when x is 2. We are getting 16. We are getting 16, but our expectation was to get something equal to 20, but we got 16, and that is when we need the comments. Okay, 16 compared with 20, the comment will be too small. Now, since it's too small, after 2, you move higher, you go to 3. Okay, calculate the value of y when x is 3. You see that? I'm getting 21. Now, getting 21, this is too large. Now remember what I said. When you get the comment too small, too large, there you stop and you start analyzing the interval between 2 and 3. You start analyzing the interval between 2 and 3, and the number between 2 and 3, exactly halfway, is 2.5. So you try that, 2.5, and see how it will behave with respect to the expected result, that is 20. So try 2.5. So calculate the value of y when x is 2.5. Okay, I'm getting again something smaller. So I'm getting 18.75. Now, 18.75 compared with the expected result, that is too small. Okay, now being too small, what does it suggest? Being too small when x is 2.5 suggests that you have to move higher than 2.5. Numbers like 2.6, numbers like 2.7, numbers like 2.8, and so on, because the result we got something too small. So you have to move higher than 2.5. Okay, so put this one here, 2.5. Okay, I'm getting something. Nope, I made it repetition, so calculate 2.6. I'm getting 19.24. 19.24. 19.24 is still smaller compared with 20, so here you write too small. Okay, but we are almost equal to 20, almost. So let us move, calculate for 2.7, for example, equals to what? Okay. Now for 2.7, we got we got the result 19.71. 19.71 still is too small because we expect to have something equal to 20. Okay, now we go to this one, 2.7, try 2.8. 2.8, what do you have? Calculate the value of y when x is 2.8. That is 20.16 is too large. Now, when you get this kind of confusion or this kind of contradiction, too small, too large, there you stop, and then you start analyzing the new interval, which will be between 2.7 and 2.8. So you start the process. So now, this time we'll be analyzing the new interval that we have got, and that is 2.7 and 2.8. So we start afresh. We have 2.7 and 2.8, and you try a number which is halfway between 2.7 and 2.8, that is 2.75. Okay, but before that, let me look for the space. Let me look for the space. Okay. Let me look for the space. Okay, now let's check how can we make a space here. Trying to look for the space. Anyway, what we are going to do is block that part B first. Block this part B. Okay, let us block this and then try some numbers which are between 2.7 and 2.7, that is 2.75. Okay, try that. 2.750. I just lost the function by here, so I have to retype it. 10x minus x squared. Okay, let us quickly type this. Alpha y equals to 10x minus x squared. Okay, so calculate 2.75. Try 2.75. We got 19.9. Okay, we got 19.9375. 9375 compared with the expected. Still the expected is 20, so this is still too small. So if it is too small, you have to move higher than 2.75. You have to move higher than 2.75, so that move higher, this will be 2.76. 2.76, calculate that, 2.76. I'm getting 19 point. I'm getting 19.989824, and this is still too small. And then try the number higher than that. Let's try 2.77. Okay, calculate the value of y when x is 2.77. Oh, now we are there to go. We got 20.020271, which is too large. Okay, we got too small, and later we got too large. So this is second contradiction, which requires you to stop here. So this the value of x to one decimal place will be 2.8. If we refer to this one here, 2.76 to one decimal place will be 2.8. How about 2.77? Still, to one decimal place we'll get the same number. So this means the value of x is 2.8. All right. Let me check how many minutes have gone. Almost approaching to 1 hour. Okay, let us go to where we blocked. We blocked this. We blocked these solutions here. Okay. We blocked the solution here. Yes. There is a solution we blocked over here. Yes. Now let us try to unblock it. Okay. Okay, now let us proceed. We have unblocked our result. The equation 10x has two solutions. One is between 2 and 3. That is done. And this one here, we have another question. The other solution is between 7 and 8. Find this correct one decimal place. Okay, so what we do, we had our function, which is 10x minus x squared. 10x minus x squared. This should give you something equal to 20. Something equal to 20. Okay, so we have to try the solutions. We have to try the interval between 7 and 8. So here we need a table with how many rows? Let me check. 1, 2, 3, 4. Number of columns, we need only 3. Number of rows, we need, let us put a lot. Okay, like 15 for example. It's too much, yeah? Don't worry. Okay, okay, here we go. Those will be the values of X. Here will be the comments. Okay. So the values of X, what we are going to try, the solution is between 7 and 8. So the values of X we start with will be X equals to 7 and X equals to 8. And we see how the results will be behaving with respect to the expected. Okay, so here this we ignore that, and then we type 10x minus x squared. This will be the comments. Now this time, the comments which I'll be using are comments to small node. Let me say smaller. Okay, we'll be moving with smaller or bigger than. Okay, bigger than the expected. The expected is 20, so bigger than 20. Now let us try to see, do we still have the function on? Yes, we still have the function on, 10x minus x squared, so we proceed with this. So try x7. Okay, try x7, we are getting 21. When you try x7, we are getting 21, and this is bigger. Okay, now why are they saying their solution is between 7 and 8? While when you substitute x7, you get 21, something bigger. We're supposed to get something smaller than 20. Okay, maybe let me try to clear my calculator. Maybe there may be some memories here. Okay, let us make our calculator normal. And let us type this. We have alpha y equals to 10 alpha x, then minus alpha x squared. Okay, now calculate when x is 7 equals to 21, still equals to 21. Okay, then equals to 21, then calculate y when x is 8. Okay, this is wonderful. When x equals to 8, I'm getting 16. I'm getting 16, something smaller. Okay, I'm getting something smaller. What does it imply? Let me check. Give me a couple of seconds. Let me check, pull out equations and pull out, that is option 3. A is -1, B is 10, and C is -20. Okay. Okay. 7. All right. It's correct. All right. Then. Okay. So. Good. All right. All right. So we are good to go. When x is 7, we got something bigger. When x is 8, we got something smaller. So that means we are going to try the interval, which is between 7 and 8. Okay, so here we try x7 here and we try 8. So let us try something exact halfway between 7 and 8, and that is 7.5. I'm sorry for the delay, but this is how maths has to work. Okay, so 7.5, calculate that when, okay, I lost the function. Let me pull out the function here. Okay. Right, so this is alpha y equals to 10x alpha x minus x squared, alpha x, okay, squared. Good, so we started with when x is 7, we got that, 21. When x 8, we got 16, something smaller. Now it's time for 7.5. What is the answer? 18 point. So we got something smaller, 18.75. So here you write 18.75, which is something smaller. Okay. Now if you go higher than that, 7.5, when you test like 7.6. Okay. Try 7.6. What do you get? Okay, 7.6. 7.6. Okay, calculate that. 7.6. Okay, we are getting something smaller than that. Okay, it's good. So 18.24. So 7.5, 18.75. If you go higher than that, then you get something smaller than that. Okay, so there is the behavior of a negative sign. There is a behavior of a negative sign, which I can see here. We have 10x minus the square of x. So that means if you keep going higher than 7.5, you'll be getting a number smaller than equals to 20, because there is a subtraction sign here. But if it was addition sign here, then you could have gone for the numbers higher than 7.5. Now, because of this subtraction sign, we have to be, this question is so tricky. So we have to go lower than 7.5 to get numbers at least approaching to 20. So here we'll be trying 7.4. Let us try 7.4. Because if you try 7.6, you get a smaller number than 20. So we will be running away from 20. We are supposed to approach something equal to 20. So let us suppose, okay, calculate when x is 7.4. Do we approach 20? You see, this is what I was talking about. 19.24. Something approaching to 20. So 19.24. 19.24. You see, it is smaller, but approaching to that answer. Smaller. See? Now we are good to go for 7.3. 7.3. Let us see if we can approach 20. So calculate 7.3. Yeah, still smaller, but going around that. 19.71. Still smaller than that. But we are heading to something equal to 20. So calculate 7.4. Let me write the number, 7.4. What do we have to get? 7.4. You see that? 19.24. I repeated the number. What is happening to me? Okay, I repeated the number. Why? Okay, I'm supposed to go lower than 7.3, and that is 7.2. Okay, 7.2 calculates for 7.2. Yep, getting 20.16. 20.16. And this is bigger than, so this is bigger than 20. So there you stop. See the confusion which I was talking about, or the contradiction. Smaller, bigger. So that means our solution will be between 7.3 and 7.2. Oh, this question is very confusing. Okay, now let us try now this new interval here, which is between 7.3, and that will be the last and final interval. So try 7.2 and 7.3. So let us try 7.25, something exactly in the middle. So 7.25. Okay, if that fails, then we'll be moving to lower. Okay, right, let us try 7.25. Calculate 7.25. Okay, we are getting something 19.9, something smaller. Okay, we are getting 19.9375. Now remember what I said? We got a number smaller. Now remember what I said? There is a subtraction sign here. There is a subtraction sign here. Now to get a number closer to that, we need to try 7.24. Okay, numbers like 7.24. Otherwise, if you try 7.25, you'll be getting a number which is even smaller than that. Let me try like 7.26, for example. You see, here for 7.25, I got 19.937. But when I got, when I tried 7.26, I'm getting a number lower than even the previous. So here we have to try 7.24. You see that? 19.9824. We are approaching to 20. 19.99824. See? So it's smaller, but somewhere around to 20. Now let us try 7.23. 7.23. What do you get? Equals to 20 point. We are getting 20.00271. Something which is bigger. So this is, see, this is smaller and this is bigger. So this is second contradiction, which suggests you to stop here, because the number or the answer they are looking for should be correct to one decimal place. Now take this answer 7.24. If you correct it, if you correct 7.24 to one decimal place, you get 7.2. If you correct 7.23 to one decimal place, you get 7.2. Same answer. You see that? So we are going to conclude. We are going to conclude our working here that our x will be equal to 7.2. This is final. Okay, for today we can stop here, and let me check the number of minutes. Okay, 1 hour 14 minutes, which is okay. And I'm sorry for this question because it was looking to be confusing. And if you have not understood, we can just you can drop me a message over here and maybe tell me to repeat this question, but it was looking to be confusing. Okay, otherwise, thank you for now. I'll be back for like after a few minutes. I'll be back taking you through inequalities. Okay, for now we can stop here. Bye bye.